Assalamualaikum and good day. My name is Muhammad Iqwan bin Rahimi. Material number 201072. I will explain about the smart fan project. Next, this is a flowchart. We start with the initialization of input and output pin, and then we receive input of surrounding heat. The heat will convert it into temperature. If the temperature is less than or equal to 26, the PWM will operate into 30%. If no, the temperature is less than or equal to 30 Celsius, the PWM will operate in 50%. Then, if the temperature is less than or equal to 35 Celsius, the PWM will operate in 75%. And if it is exceed that 35, the program will end. Next, we will have a look at the program one by one. So before we proceed, we need to understand the ADCON 0 and ADCON 1 register. For ADCON 0, it has for bit 7 and bit 6, it is added with the ADCS2 in bit 6 of the ADCON 1 register. These bits will represent the prescaler of the ADC. Next, bit 5 and until bit 3 is present the channel select bit for ADC. And then for bit 2 is present the conversion of the ADC, and bit 0 represent the turn on of the ADC. ADFM. Next, we will have a look at the code. So we use internal frequency of 20 MHz. We set it in the header file. For ADCON 0, we get this we set this number so that the add-on is the ADC is turned on, and the prescaler is divided by 2, and the channel is set into 0. So for ADCON 1, we set this one at FM so that it is right justified. Next, for ADC read, we do the bit masking ADCON 0 and with this number so that we clear the channel select bit, and then the answer will be all with the channel. The channel here, if you choose 2, it will convert into bit, so it will be 0, 1, and then it will shift to the left 3 times. So we will all with the number, and then the delay 2 milliseconds, and then we do the ADC conversion. After the conversion, the result will be restored in the address hash. Next, for main, in this main function, we set the temperature, which is useful for the calculation of conversion, voltage, heat conversion into temperature, and then we put the ADC in it, the previous initialization for ADC, and then this 2 is the output of the program. PR2 is PR2 T2 con is useful for the calculation of the time for the 1 cycle of the PWM. So let's have a look how we calculate that. This is T PWM. We calculate with the 4 times with the T internal time times with the PR2 plus 1 times with the TMR2 prescaler value. Since with PR2 previously we choose FF, hence we convert it into decimal number. We get this number, and then for 1 cycle we get 51.2 microsecond. In the while loop, we convert the heat received into temperature first by times with the 4.88281. This number is actually 5 divided by 1023. The answer will be in milli, but for the next step we divided it by 10 10 here is actually milli, since 1 Celsius is equal to 10 millivolt, so the milli will be cancelled out. Next, then we get the answer. If the answer is less than 25 Celsius, we set the PWM into 30%. How this is possible? We have a look at the calculation here. T height is equal to, this number 307 is actually CCPR L number cascaded with the two number of first CC21 con hexadecimal here. Then it will become 307 times with the TMR2 prescaler. Hence we get this number divided by 51.2. This is full cycle of the PWM times with 100%. We get 30%. Next, if the temperature, we do the same thing. If the temperature is less than 30 Celsius, we set it so that this number is equal to 512, and then after the calculation we get 50%. Lastly, we do the temperature less than or equal to 35 Celsius. We set CCPR1L and CCPR2L into so that it will become 768. We get this number divided by full cycle of PWM times 100 is equal to 75%. I think that's all for me. Thank you.
Assalamualaikum. Hello, and my name is Abdul Hakim Berosad, and my metric number is 200866. So in this video, we are going to see the schematic of the smartphone project, and we're also going to test the circuit by using the Proteus simulator. So here is the schematic of the smartphone project, and in here we can see there are 3 LEDs that we use, 2 motors, 1 driver, and also 1 input, which is the LM35, the temperature sensor. Now here is the PCB layout. This PCB layout we constructed by using the easy EDA in the internet, and here is the result of it. And to make it more visualized, we use the 3D visualizer, and in here you can see there is 2 ports that we use for connecting to the motor, and also the H3 to connect with the battery source. Here now we are gonna run the simulation for the circuit. So firstly, what we're gonna do is to insert the hex file or the coding file from the compiler into the PIC16. So just in doing that, we need to double click the PIC16, and then what gonna happen is that there will be this pop-up window, and what we're gonna do is just find this hex file and just insert in it and just press OK. And then we are ready for the simulation. Okay, so here we're gonna test with a lower frequency, lower temperature, which is 24 Celsius. Okay, so let's go. Okay, so now here you can see that there are 1 LEDs turned on, which is the D1 that connected to RB0, and also we can see that the motor seems to start to gain more power and rotation. Okay, so now we're going to test the second condition, which is the higher than 25, and we put it at 28. So now at 28 Celsius, there are 2 LEDs now that turn on, which is DC1 and DC0, and the motor seems to gain more power and rotation from the PWM duty cycle. And we're going to test the last condition, which is the more than 30, and we're going to put 35. Now we can see that there are 3 LEDs and all of the LEDs has been turned on, just like what the program says, and the motor seems to gain more power. As you can see here, the RPM seems to be a lot higher than before. And now after we put the temperature more than 36 or more than 35, the LEDs will all be turned off, and the motor will stop gaining power and will be starting to go for 0 RPM slowly. Okay, so Okay, so you can see there from 0.08 it goes to 0.07. Okay, so it seems that the simulation is successful since all the condition has been exactly happen as what we want it in the coding. So I think that's all from me and that's all from us, and thank you and assalamu alaikum.